Hello, class. This is lecture 0 for electromagnetic field theory. And I'm Scott Grenquist. I'm your professor. There's my motorcycle keys. I just found in my pocket. I was saying, what's sticking in my pocket there? I just finished what was supposed to be a half-hour motorcycle ride, but turned into an hour-and-a-half motorcycle ride. So that's why I was sort of a little late getting this lecture 0 off and shooting an email to you. But I'm already way ahead of that for the class anyway, as you knew I would be, because I'm Professor Grenquist. So I have already done many asynchronous lectures for the previous spring semester classes to finish those off. I haven't done any Zoom lectures yet. So, you know, I'll probably try to do that on Friday to at least get us together so that we could meet and really have a Zoom meeting more so than a Zoom class. I want to keep this as flexible as possible over the course of the summer. By now, you will have all received one of these. Yes, a blank sheet of paper. No, it's, I'll try to get it in there. It is the syllabus, of course. And hopefully you've got it on your computer or you've printed it off and you're looking at the syllabus. And I want to go over the syllabus with you. I've put all of the lectures. There's 4 lectures up there, 4 or 5 lectures up there. I can't remember. And this would be the 5th or the 6th on YouTube. And it's on YouTube. Of course, if you're watching this, you've already gotten there. But you just go to Scott Grenquist channel on YouTube, and I have that. I also have other lectures on there for AC network theory, which I was sort of finishing off with the mechanical engineers for their introduction to electrical engineering course that they have. And I also put a couple other lectures on there too. But I've put 4 lectures for this class, at least 4, as I can remember, up there. But this lecture 0 is really to go over the syllabus and to go over the class structure, especially the class structure now in this new environment that we find ourselves in. And, it's a huge thing. The coronavirus is a huge thing, even for me, and I've lived forever, as compared to you anyway. You're going to learn, and this is a class that is a very interesting class. I have, done a lot of work and taken a lot of courses, both at the undergraduate and graduate level in electromagnetic field theory, and we're going to look at it from a lot of different angles. And I want to show you the applications, and I want to show you, really what's going on, so that you can understand it conceptually. So let's look at the syllabus together, shall we? That's my name up there. That's my office phone. You could call my office phone. I should have put my cell phone on here too, but I didn't. And I don't know, I'm still thinking about that. But I'll probably give you my cell phone too. But we'll still have meetings where you can ask me questions and everything like that. Course description: this course introduces static electric fields and magnetic fields, and that's really magnetostatics and electrostatics. So we're gonna do that with the textbook that we're using, Forzan. You probably already looked that up since you have the syllabus, but time-varying fields are studied using Maxwell's equations, and really understanding and looking at Maxwell's equations, understanding also that they're not Maxwell's equations. No, they were a whole bunch. There are Gauss's equations, there's Ampere's equations, there's Faraday's equation, and all of those together with the extra bit, the realization that Maxwell had about that. And then also, once Maxwell had that realization and put that in Ampere's equation, everything came to light. It's a pun. Only electrical engineers would really understand that, but everything came to light in the fact that he realized that it was like the second order partial differential equation for velocity of waves in waves, in harmonic waves. And so he immediately realized that, oh my God, light is a wave phenomenon, and the rest is history, like Einstein said. You know, who was it that said Einstein followed in the footsteps of Newton, and then he corrected him and said, no, I followed in the footsteps of James Clerk Maxwell. And so it's a fantastic field, and it'll really, you know, expand your mind, but it'll also expand your mathematics, because several of these things that we're looking at, both scalar fields, vector fields, you know, what are those? And what are the mathematics that work with those? And what is the del operator? And what is a gradient? And what is divergence? What is the curl? So these are all mathematical properties too that even extend outside of electromagnetics that you should, and especially if you're considering ever going into graduate school in, you know, technical field like electrical or computer engineering, you should know these things because you're going to use them. So, so yes, and I want to talk about, you know, the lecture structure, the assessment structure, and everything else in this lecture 0. Since I've already made a lot of these lectures, these asynchronous lectures that you're watching on YouTube, I know about how long I can go and still get them up on YouTube, because YouTube limits you to, I think, 128 megabytes per video, and that comes to about 30 to 35 minutes. Yep, is everyone getting seasick? I'm just trying to fix that so that it's a little better, but I guess that's fine. All right, let's get back to the syllabus. Course goals and objectives. The student will have the ability to manipulate Maxwell's equations using vector calculus for the purpose of investigating static, time-varying electric and magnetic fields. So both static and time-varying electromagnetic fields. And of course, the real interesting ones are the time-varying ones. They're not so much the static ones. But of course, you've got to understand the static, and you've got to understand electric fields and the potential field within the electric field. You know, equipotential lines, you know, electric field lines. So all of that, and to understand vectors too. And so that's where engineering mechanics, of course, comes in so handy, and your understanding. And I know that some of you, not all of you, I don't think, but most of you have had me for engineering mechanics. So your knowledge of vectors there and vector operations, of course, are going to help you in this course, because that's all it is, or a lot of it. All right, the student will realize why and understand the need for advanced study to become proficient in this area. Well, that's true. I mean, really, we're really at the beginning of what is a 4-series sequence. I must be on mirror image. No, I'm not. I'm not on mirror. Oh my God. Anyway, so this would be like sort of the first and half of the second course, if you can take it. I'm also going to try and throw some other things in there too. And since it's asynchronous, you can take as much as you want, and we can sort of see how far we go together with this. So anyway, let's go on. Student outcomes, that's just for us and for ABET accreditation. Credit hours, 3 lecture hours, which makes it so easy to do with a summer course. Of course, laboratories are great, but since this course didn't have laboratories, and I've always pushed for laboratories in this course, but now that we've got COVID-19, I'm glad we don't. You know, whatever. This is how it was designed, so this is how I'm teaching it, and it'll work out a lot better. Those are our meeting times, and again, I will probably always have try to have a Zoom meeting at those times, unless I tell you beforehand we're not going to, or maybe we'll find out we don't need it, or maybe only 2 people show up for the Zoom meetings I have at those times. I don't know how it's all going to work out. pedagogical approach, teaching strategies. Homework will be assigned periodically. As you know, I'm going to give you homework. You're going to do the homework. You're going to give it to me. I'm going to grade it. It actually, for this course, because I've also decreased it by one test, the homework becomes significant now. It becomes 20%. So really, I'm going to be giving you, a bit of homework assignment, but you're going to have to do those and then send it back in to me. And I will exchange my commute time for grading time, and we'll probably have more homework than usual, right? In a course, but I'm getting rid of one of the tests. Okay. So also all examinations, that's midterm exam and final exam, will be cumulative from the beginning of the semester. All tests will be cumulative from the previous test. So test 1, I'm only having 2 tests. So test 2 is going to cover everything from test 1, and test 1 is going to, so yeah, don't worry. You're going to have a lot of testing and assessment, but I want to say one thing about that. At the faculty meeting that we had earlier today, it came out that there's been a lot of cheating that's been going on in the spring semester, 10 times what it was usually. And in fact, it seemed like from what people were saying that it's more like 100 times. So all I have to say about that is there's nothing I can do about it. There's nothing I can, I'm not, this is extraordinary circumstances. And this is when a person's character comes to fore. And so I don't expect that any of you would ever think of cheating on any test that I gave you. And I know you won't. Anyway, students are allowed a 3x5-inch formula card, and you'll still be allowed that 3x5-inch formula card on the test that I send out to you to do and then send back to me to grade and assess you with. The text is Ulaby, and I have it here somewhere. I thought I had it right here. Oh yeah, here it is. Right underneath the syllabus. Well, of course it would be hiding. And anyway, let's look at this now. This is Electromagnetics for Engineers by Fawaz T. Ulaby. I believe there's only one edition, so you don't have to worry about getting the wrong edition. And they're doing a tango. Yeah, it's a tango. Yeah, don't ask me. But it's a pretty good book as you move through the concept, especially a first course or first 1.5 courses in this. And when I say 1.5, I'm going to also use, at the end of the course, I want to talk about fiber optic transmission. Right? Fiber optic transmission, I did a lot of my master's research and stuff in that from the very beginning, and got into a lot of interesting things, and fiber optics still is a black box to so many people. So what we really want to do with Fawaz T. Ulaby, by the way, I think there's got to be a PDF of that floating around out there someplace. If you wanted to download an electronic copy, I'm sure that that's there. Now, when I send out your homework, which is going to be out of that textbook, I'm going to actually send you copies of the homework problems. I'm going to scan in the problem, page out of Fawaz T. Ulaby and send that out to you. So you will have the whole problem all laid out in front of you. You won't have the book, of course, but you'll have the problem laid out in front of you when I send it out. And I will also send out, so I'm going to send out like 2 things. One of the problems that I want you to do in Fawaz T. Ulaby as we move through the course. And then another document that would be, because I can't put this on reserve in Wentworth, another document that will be a resource document, Let me make that clear. It's a resource document that you could use that has the solutions only to the problems that you are being assigned. And if you work on the problem and for an hour and you can't get it, and there's something that's sort of something, look at that part of the solution to get you by that and try it. Only by doing the problems and by exercising your mind to see the patterns and trends in the solutions of the problems will you be able to then do that on the test and then have that knowledge ingrained in your mind forever. Okay, so that's good. Resources, whatever Wentworth can help you with now. You can't go to the Center for Teaching and Learning, that's for sure. Wentworth attendance policy. Why am I even talking about that? You're going to do the work that I'm going to give you and read the stuff I'm going to give you to do the work I'm going to give you and to look at the lectures. I mean, you're going to have a lot of lectures that you're going to have to look at, like this lecture on YouTube. There's going to be probably about 40 lectures altogether. And those will be up there very soon, all 40 of them. I mean, I love teaching electromagnetic field theory, and I've taught it a lot in my 250 years of teaching. And then I did a lot of work with it in graduate school too. So I love electromagnetic field theory, and I could just, this is, we could go on and on and on for 4 courses, 4 3-credit hour courses, 4 4-credit hour courses. There's so much to learn. Antenna design, and we're not going to get to all of those things. We're not, but we're going to get to a lot of fundamental concepts in electromagnetic field theory. So, and as engineers, that's what we want to understand. We want to understand it at the base calculus, differential calculus level. That's what we're studying. We're not studying antenna design at Radio Shack. Let's, anyway, assignment submitted, work late, all homework's due, next lecture class, I don't know about that. I'll tell you during the lecture, when the homework's due. When I send the homework out to you, I'll tell you when the homework is due at such and such a time throughout the course of the 15-week summer semester. You have to do the homework. No, you can't photocopy the homework and send the homework in. Well, I guess you're going to scan it in and send it in to me anyway. But I don't really, want something where 2 people's homework looks exactly the same or something like that. You can't, in other words, don't photocopy each other's homework and send it in and think that actually qualifies and then the name's crossed out at the top. No, don't do that. Okay, don't do that. Everything's going to be fine. Test 1 will be somewhere around the last week of May. Like I said, I want this to be sort of a flexible semester. There's a lot to learn. You're going to learn it through watching my lectures. My lectures will have all of the information in them that you'll need to do all the homework problems, to understand electric fields with multiple point charges, all of that. I'm looking out my window now, which is just zaps my mind away from this lecture. I've set up my studio in the back of my house. I live in Hull, and I live on the bay in Hull. My backyard, my backyard is the bay in Hull. And it's a beautiful day outside. That's why I rode the motorcycle. So anyway, and the whole back of my house here is glass. So sometimes my attention is drawn away by a seagull going across the deck or something. All right. So midterm exam is going to be mid-June, and that's when the midterm grades have to be on June 23rd. So it's going to probably be around June 15th is going to be the midterm exam. Mid-July is going to be test 2. And so that's gonna go a little bit further than I would usually have test 2, but then I'm sort of lumping, because I'd usually have test 3 in like the last week or so, right? To hit you from the material we've just had. You get a little more material, which is like one problem on the final, but that's not how I'm doing it this time. So from mid-July all the way to the end of the course, we're not having anything. All of that material. So you can imagine, instead of one question I'm going to throw into the final, it's going to be like 2 or 3 questions on that stuff from mid-July, maybe 2 questions on the stuff from mid-July to the end. And so, you know, it'll be a good class. Again, it mentions at the bottom, 1 formula card is allowed for use on each test, and 2 formula cards are allowed on each examination, written on both sides. Formulas, no worked out homework problems, just like we would do if we were, if I was proctoring you and sitting in the class right in front of you, which you probably know I am. No, of course I'm not, but that brings up an interesting point that Professor Duva made this morning in the lecture. He said they finally got to the point that they had everybody, you had to take the test in the Zoom meeting for 2 hours where he was watching everybody. But just, yeah, it's never getting there. Where we're getting is back. We're going to get that vaccine working, or we're going to get that, new test. That's a 24-hour test, and it costs $1. The military is putting out mid-May, and pow, we're going to test out. It's a blood test, and everyone's this. I'm going to look back at this video in 20 years, if I'm alive then, and just think to myself, what was I saying about that military test? But yeah, or it might happen. And what they can do is they could test everybody in the whole country. It's a blood test. Everybody goes and gets a blood test. We find out immediately who has COVID-19 and doesn't even know about it. In fact, you can have COVID-19 for 4 days without being infectious. So if we could catch people before they're infectious and they have it, then we could quarantine them immediately and just stamp this whole thing out. We've got to come up with some type of system or vaccine or vaccine, but that's the golden bullet. Maybe a system is better. Anyway, I'm talking too much about that and not enough about this. That's what your grading is going to be. You've got 2 tests, and those 2 tests are going to be 15% apiece. And then the homework's 20%, and you're going to have, a few homework assignments that you're going to have to do and send in to me. Midterm examination, 20%, and then final examination, 30%. So the 2 examinations are still they're cumulative. They're the main things that you've got to do and hand in to me. I'm going to mention another thing here too. I'm going to make these take-home examinations. I'm not going to make these, I'm not even going to use the charade of saying, okay, I want you to set a timer for exactly 1 hour and 50 minutes for the midterm. I'm not going to do that. These are your seniors, do the thing I'm going to make them harder on purpose, but instead of 2 hours, it might take you 5 hours to do it and to make sure that and then double check and everything else. I could say these are open book, but I don't want to go to that, because once you get into open book, that then it brings in example problems inside the book that you can then look at and see how people solved other problems to then solve this problem. That is not learning. So the formula cards and stuff that you have, I'm going to limit it to that. If for some reason you can't remember what pi is and you have to look it up, look it up. Maybe I didn't put in the test what the charge on an electron was. You should know that. But it's minus 1.602 times 10 to the minus 19 coulombs, in case you forgot. Now let's get back to this. Class communication, predominantly it's going to be email. I really, I'm going to stick whatever I have to, my syllabus up there on Blackboard, but I don't want to work with Blackboard. As these lectures go on, I'll probably explain why I'm not doing that. I mean, not Blackbird specific, but that type of platform. I'm much more comfortable with a video type of platform, and I'll explain that to you later on in the videos that we're doing. Also, important dates. Oh my God, I put the wrong thing in there. I better change that before I send it out. Uh, yeah. So anyway, you know the dates. We're not going to have anything Memorial Day, I think, and we don't have July 4th. So, and then I think it's August 5th or 6th. 5th, I think, is the end of the semester. Academic conduct and honesty. God, I'm glad I printed this out before I sent it to you. Not that last one, the one before that. But hey, what the heck. Academic conduct and honesty, and then Scott Wentworth's academic conduct and honesty policy with a hot link, and you can go and look at that. I thought instead of sticking it in here, I would put that. And they said that we could put a hot link into that so that we just don't keep cramming stuff in here. All right. I'm going to look at one last thing because look at the lecture syllabus. The lecture syllabus is something that I want to go over in more detail, but I feel that I'm already, I don't even know how to gauge how long this has been recording. I mean, shouldn't it tell you, like, I've been recording for such and such a period of time? I don't even know. I don't want to hit that thing. I'll figure these things out. I've had a lot of other things to do that were more important, like taking a couple of weeks off after the spring break to ride the motorcycle and other very important things, painting, stuff like that. So I'm going to go through that with probably lecture 1/2. And I'm going to skip over that, and I'm going to go to the last page of the syllabus now. And all homework should, and I'm going to just go over this for a second for people that have not been in a class I've taught before, and I think many of you have been in a class I've taught before, be turned in on quadrille paper. Make it professional. Have in the upper right-hand corner your name, my name, class name and number, and the list of problems that are being submitted in that thing. Box all problems, box all answers, make it look professional. Look at it as if you're putting together, some type of calculations for your supervisor at, I always like to say Raytheon, but, because a lot of our students do go to Raytheon, but it could be Bose, could be EMC, could be so many things. And then the last one down here is something that I have to include. Actually, your grades will all be higher than really the numerical definition because I grade on a curve and I give harder tests. And that way, your scores, like when you come up and you get an 80 out of 150, I've had this happen where someone has come up and said, hey, I got an 80. I should get a B. I said, no, that's 80 out of 150. She said, well, it's an 80. And I said, no, I'm sorry. It's, it's if you 80 divided by 150. And then she immediately, it just dawned on her because she's an engineer. And she realized that she had made a mistake. But, these things, like I say, on the revised grading policy, even though, she still ended up getting a C. And that's what you're going to get too, because I grade on a curve, and a lot of times my median for the curve, might be, at 110, and it could change, and it depends on the day, it depends on the class, it depends on the tests. And of course, tests change every year, classes change every year. So the only way to really make it equivalent is to grade across the Gaussian curve that you have. Okay, so like I say, this is something I have to put in here, but it really doesn't mean much of anything. I'm going to end this lecture 0 now, and then I'm going to make a lecture 1/2. Now I don't know if I'll get the lecture 1/2. I'll get it done today. I don't know if I'll get it done before I send the email out. So I'll send the email out, and the email will really say probably watch lecture 0, which is this lecture. And in this lecture, I'm saying go ahead and watch lecture 1/2 because I'm sure it'll be up there. I just don't have it up there yet, but I do want to get the syllabus out to everybody. All right. I'll see you at lecture 1/2. Not 1/2. Because I don't know why I'd make lecture 1/2.